Hello everyone, welcome to my talk. It's called Your Own Annotation Processor. And let me ask the first question. How many of you are Android devs here? Oh, plenty, okay. So it's not going to be boring to everyone, so that's great. My name is Gabriel. I'm senior Android developer and tech leader in Netguru. And today, well, spoiler in the title, we are going to create an annotation processor. So the next question to you is, have you ever used annotation processor? Anybody of you have used annotation processor?
No, I never used it.
Clever one. Yeah, because if somebody will tell that, nope, for sure, never use it, you are lying probably, because I'm really doubt it, mostly because I really doubt that you have never used any of those libraries, like Dagger for dependency injection, maybe Room for like wrapping your database, or many other like Butter Knife, which is not used anymore probably, or data binding. Every of this library is using the annotation processor under the hood, and you might ask why. Mostly because it reduces boilerplate. So imagine using like retrofit and having to write every API call by hand and making sure you're parsing everything properly. It will be like loss of time, right? Annotation processing improves runtime performance. So it means that if something compiles, then it will work, right? You don't have like runtime issues with Dagger. With Coin, you can have, right? So if Dagger will compile, it will provide your dependencies. Also, it's compile time. So if it has like compile time safety. So that means that everything is compiled before providing to your app. So even you can take a look into the code, and I encourage you to do so, to check how Dagger makes the whole dependency graph for you. And most important, it's fun, because annotation processors can create the code for you. So it's like creating the software that creates the software, and it's like another level of programming. So yeah. Maybe let's start from the beginning, because I talked about the processing, about annotations, but let me talk about annotations from theory perspective at the first place. I bet every one of you knows annotations. We have plenty of it. There are like more or less fancy ones or boring ones, but let me explain and tell you what does it even mean. So we have like this get annotation. It's from retrofit. I can imagine everybody of you is familiar with that, right? So it provides the information about which API is gonna be called, right? There is no logic of calling this API, right? We are only providing some kind of information. And this information can be processed. It can be processed under runtime or in the compile time. And annotations were introduced in Java 1.5, so it's for a while and it's widely used. But annotations without any processor are only an information. It doesn't have any logic, as I said and mentioned before, and I will be mentioning it all over again. So we need something to do something with this annotation, and then we are talking about the annotation processing, and for that is responsible KAPT, so Kotlin Annotation Processing Tool. Have you heard about it?
Yes.
Great, because it's not valid anymore. We are gonna talk about KSP. So that's something that is something new, something very cool, and it's really hot deal for you. So if you can, I recommend you to use KSP. And many of libraries are migrating to the KSP. Now, I believe Dagger have some version with KSP enabled. Room, I'm almost sure is in the production with it. So many famous libraries are taking advantages of the KSP, and I'm gonna base the rest of the talk on it. So, how does it even work? We can have this diagram that I stole from the internet. The first step when annotation processor works is that during the compilation time, we are looking for any unprocessed source files with annotations. So let's say the retrofit annotation processor is looking for each file. You have the get, post, delete, put, etc. method in it, right? And if it's gonna find it, we are trying to redirect them to the processor to process annotation. And what the processor can do with that? Almost everything. Almost everything, because it can create some source code from it. It can error, for example, abort the build. So you can have like some bookmarks in your application that you can mark that, okay, crash me it, and it will crash the build time, because you don't want to have this code in the production, for example. And it goes in this loop of finding the source files, processing them, and it goes around and around. And if you ever write a for or while loop in your life, and I assume that you have, you will notice that there can be a little problem here, that this thing can go in infinite loop, right? So let's imagine the scenario in which when we are gonna process annotation, let's get this post annotation from retrofit, we're gonna generate some code that will have another annotation, let's say get, and it will go and run and never compiles, right? So that's why annotation processing have only one rule, that it can only be used to generate new files and not to modify it. So if we are gonna have like this, let's say, user DAO from room, it will create user DAO EMPL, right? It won't modify your file, but create another one for it. And it applies to all annotation processors, to all annotation processing world. Oh, almost everyone, because here's the Lombok who doesn't care about it. And I'm not sure if you're familiar with Lombok. This is library used back then in Java times. When annotating via Lombok, we could generate getters, setters, equals. So basically all the stuff that data class provides out of the box, right? And Lombok doesn't give a hell about this limitation, because it was like modifying the original files, but just in theory, because Lombok is like combined two approaches. It uses annotation processor and compiler plugin that merges the two files into one. So it's very clever idea and very clever way to take benefit from both ways to create the one library. And of course, we don't need Lombok right now. We have data classes, but it's just a good way to to consider how can you benefit from combining two different approaches. So okay, so we have like some theory. So we know what annotations are and why we need them. Let's find out how to create our own annotation processor, because that's why we are here, right? So what we are gonna build? Actually, I thought that the best idea is the one from the real life scenario. So let's create a simple annotation processor that will generate DTO class from the Samojło class, so the very straightforward data class. So I want to achieve something like that I have like plain data class user with some fields, ID, email, account balance, etc. And I want to have annotation, auto-DTO, and to mark my class, auto-DTO. And what I want to achieve is to have generated the class user DTO with all the annotations that we are using for the networking. So it should be serializable, have proper serial names, etc., etc. And yeah, that's from like a real project. We have some fun building that tool. Was it not beneficial? Not at all. But it was only for fun, for fun purposes. So it's working on production. But yeah. So what we need to do? For sure, we need to have like two modules. My library and my processor. So in the first one, we are gonna have our annotation. The second one will be responsible for processing them. Let's create annotation. It's all it takes, like 3 lines of code, and we can omit the first 2, to be honest. First, we need to specify the target of the annotation, and the target is basically where you can put your annotation, because we can have their like class, field, constructor, getters, method, etc., etc. So we have plenty of options here. And the second one is retention, and retention is more complicated. It's responsible for how our annotation will be stored in the final source files. So we can have the source one. So it means that annotation is only in the source file. It won't be compiled into the binary one. So if we are gonna reverse engineer our application, it won't be there. The second one is binary. So as you may know, it will be stored in the binary. But it won't be visible via reflection. So reflection is another way of processing annotation. So having it set to the binary, we won't be able to process them that way, but it will be visible in the binary. And finally, the runtime, the last one. This is the remaining one, so it will be stored in the binary output, and you can process it in the runtime. So, for example, coin is the best example, I believe, that takes benefit from having annotations that are processed in a runtime. So let's navigate to our second module, so to the my processor module, and let's add a bunch of dependencies. We are having the Kotlin poet. I will explain it a bit later. Some stuff from, JetBrains Google, that's boilerplate code, let's say. And something worth to notice that we have like compile only, because we explicitly set our annotation as the source, that the one that will be stored only in the source code, not in the binary code. So that's why we can have our library as a compile only during the compilation time, not on the runtime. It's like not required. We can have implementation here as well, but yeah. Okay, let's start with building our processor. So the one thing, and the only one thing that we need to have in our processor is the process method. And we are gonna query all the annotated symbols, providing the full qualifier of our newly created annotation. And basically that's it. I mean, that's it for having the annotations being queried. So we can filter them by validate ones, so we can be sure that it met the requirement of where this annotation was placed. So in our case, on the class. We are filtering the instances, and for each of found annotation, we are gonna generate file, because we are annotating the file user and want to create the user DTO from it, right? I know a lot of code, boring one, but I will just briefly walk through it just for sake of having what is done step by step. So the first two lines we are trying to create our new name, right? I mentioned that we cannot modify existing file, we need to create one. So let's have the original class and put the DTO suffix for it. We are remaining the original package name. Now we are using the builder, and that's where the Kotlin poet comes in. Without that, we would have to use the very long string with some placeholders in it and create this all, data class and inject there our name, etc. So it doesn't make sense to do it. It will be hard, unmaintainable. So we have the Kotlin poet, so basically the tool for generating the code for us. We are adding modifiers. Here there is the data, and adding an annotation serializable, right? Very easily. Adding constructor and jumping into that, how it looks like. Sorry. We are just getting original constructor and adding the parameter. So basically copying the existing code. I'm not gonna go step by step, but if you would like, I have the link to the repository, so it will be probably easier to download and go through it on your own. So we are copying each constructor parameters to our newly created file. The same goes with the properties. So each property from the original file, we are moving to the newly created one. We are adding also annotation. Do not forget about it, because we want to have on each field the serial name annotation being added for us. So that piece of code is doing it. Also Kotlin poet, so nothing really invented by me here. So it's just using the library here. And at the very end, we are building the file itself finally, so providing the package name, the file name, and we are writing it to the newly created file. And what's very interesting here is that we have the write to method, right? That is having the dependencies that can have be set of. We can set the aggregating param to true or false. What does it mean? That means if it should provide basically the import to the unknown classes, because if it's gonna lay in the another package, then it will solve this issue for us. So it will create the proper import. We do not have to manually create them. So this is very cool stuff. The one weird thing at the end of the whole process is to create something that is called symbol processor provider. And believe me or not, I've never spotted this let's say approach. Is that we are creating the processor, and on Android we are not doing this much often, but we need to add the full qualifier to the proper catalog. Resource meta inf services, com Google dev blah 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 blah, and to point there in this file we need to have this content inside it, fully qualified our name of our processor. And I said that it's not common. It's actually common on the backend side. I believe Spring uses this approach a lot. On Android I spotted the annotation processors. And I believe Detect custom plugins for Detect are also being hooked like that. It's not common. It's looking weird, but that's the way it is. And at the very end, it's our app module Gradle. I should put it on the slide probably. That we are gonna use as as any other library to our project. So we need to implement add implementation on the project and KSP on the annotation processor. And small reminder here, if you are still on the KAPT, instead of KSP, you will have the KAPT obviously. So that's something you for sure have in your build Gradle files, a lot of KAPTs already, or hopefully KSP. So let's have our class, finally. We have created the annotation processor. Now we can create the simple user class with desired parameters. We are gonna annotate it with the auto-DTO annotation, and we are gonna build the file. Ta-da! That's what we are gonna have right now. Obviously, it's not gonna lay in our packages. It's gonna be under a certain directory. It's gonna be like build, src outputs, etc. So you won't be able to see it in your project hierarchy. And also, it will disappear if you're gonna clean your project. So that's something from to remember. But we have it. We are able to use it as a normal class. And from the code review perspective, you are not able to see any difference because it doesn't matter for the compiler and for your colleague is that class written by you or generated by our annotation processor. And to go further from this, because I really don't want to, show you another slide with the code and explaining how we can build with it. And we actually can build a lot of stuff in one of the projects I built. We have like mappers from DTO to entities completely being generated. So, it's only matter of adding a mapper annotation. It will be created and provided by annotation processor. But the most powerful things achieved by annotations processor are probably those two libraries. It's Room and Dagger. The core functionality of these libraries are based on annotation processors, and I really encourage you to take a look in the source code. I'm not sure about Room, but Dagger for sure have its open sourced, so you can take a look specifically in the KAPT, I believe, source code of it, or Room into generated code in your own project. If you are using Room, just double shift and make your user DAO EMPL, and let's take a look how much of a code is generated by you, so you do not have to worry about all these transactions in database, etc. The next topic, very interesting, is reflection. So the second way of annotation processing, the runtime one. So annotation not being processed on the compile time as on the Dagger, but in the runtime, as in Coin, for example. It has pros and cons, obviously, but it's something very, very cool to look into that. And once again, compile plugins. The thing that Lombok is using to trick us into cheating on annotation processing rules. So that's also a very cool thing you can achieve there. And as I promised, here is like a QR code with to the repo. Recently, like a few months ago, I've introduced a PR which changes KAPT to KSP implementation, so you can see in that details how big of a changes there is. And spoiler alert, it took me like 2 hours to get myself from KAPT to KSP to check the differences and to make sure it works. But but my project is not very big, right? It's like one small annotation processor. And I really encourage you to take a deeper look into those topics. It's really fun. It's metaprogramming, because that's how it's called. It's like another way of programming. and I really encourage you to take a shot of it. And who knows, maybe you will be another creator of Dagger, Retrofit 3, I guess, or maybe Lombok 2. Thank you so much. And in case of any questions, I'm here, open for you.
Thanks. If I'm trying to write a simple processor, what kind of API do I have to the market class, for example? Do I have an access to AST, or I have some...
That's a good question. You do not have like access, if I understood your question correctly, you do not have like access to the file itself or to the classes itself. You have access to the classes that are currently in your code, but it won't allow you to like go one by one, line by line in this code. You can use the API based on this resolver that can provide you many different things like parameters of the method, like return type, modifiers, etc., etc. But you are not really able to, check if this. I cannot even imagine what you want to achieve with that, but to check like how many letters are in the 51 line of such file, for example. So it's limited, but I'm not really sure if that's a problem here.
So that's an abstract syntax tree.
Yeah, that's abstract syntax provided by this whole API from the KSP or KAPT. Yeah.
So in the generated DTO class, it started with a set of imports. Mm-hmm. So were they generated automatically, or do you explicitly?
No, that's the best thing, that we have this write to method that takes dependencies, aggregating through. That is responsible for generating the import. When set it to false, you will be responsible for yourself. I believe that's for flexibility, because maybe you want to import some other package with the same name or something, but you can do that. Thanks. Any other questions? Thank you so much.